Hey guys, this is Mrs. Bell. We are going to be going over bits and pieces of information that you have learned from some of your previous cycles. And we're going to learn about how all of these bits and pieces of information fit together and what you can learn about elements using that. Okay, so let's start off with a little bit of review first. In cycle 2, you learned about atomic structure. What are protons, neutrons, electrons? How are those electrons arranged in the energy levels and or electron cloud? And how we count up the protons, neutrons, and electrons in an atom. So on the left side, we have some information about electron arrangement. It is really important that you remember that energy level 1 can only house 2 electrons, and every energy level after that can hold up to 8. Calculating protons, neutrons, and electrons. You guys are starting to get really good at this one. You guys know that protons and electrons are always going to be the same exact number, and that's going to be equal to the atomic number. We're going to bring that up again on another slide. Calculating neutrons is always going to be the mass minus the atomic number. I always like to say it's bottom number rounded minus the top number. Those two numbers that I'm referring to are the two numbers on an element tag or box. Okay, we learned in cycle 3 about valence electrons. Valence means outer, so all of the electrons on the outermost ring. These electrons are similar to your skin, and your skin determines how you react to your surroundings. Valence electrons determine how they are going to react to surrounding elements and atoms as well. So if an element has one valence electron, that means it's going to be most reactive. These are the most dangerous elements on the periodic table. If an element has 7 or 2 valence electrons, it means that it's going to be highly reactive. Now I added a note in here saying that this excludes helium. Helium has 2 valence electrons, but like on that last slide said, where the innermost energy level can only house up to 2, helium has 2 valence electrons, but that means it has a full outer valence shell, which means it's going to behave like all of the elements in group 18 with 8 valence electrons, which means that they are all incredibly stable and non-reactive. Any elements that have valence electrons that were not mentioned in this list are all going to be considered mostly stable. That doesn't mean they're always stable. It just means that most of the time they're going to be stable. All right, so periods on the periodic table. These are our rows. And the reason why they are important is they indicate to us how many circles or energy levels an atom is going to have. So based off of a picture, we can figure out what period it's going to be, or based off of where it is on the periodic table, we can figure out how many energy levels it's going to have. Same thing with valence electrons. Group 1 has 1 valence electron, group 2 has 2 valence electrons, group 13 has 3. So I like to tell my students on the star periodic table, there is a number in front of the letter A. That number is your hint for the number of valence electrons for that group. Group 14 has 4, 15 has 5, 16 has 6, 17 has 7, and then group 18 all has 8, except for helium. As explained before, helium only has 1 energy level where 2 valence electrons can fit there. So it's considered full and happy and stable, just like the rest of group 18. The 2 locations on this periodic table that have X's, those are locations where we cannot predict valence electrons. But as far as we need to know for now, all of those elements underneath that X are mostly stable. All right, so talking about reactivity, this is a really great chart to write down if you don't have it in your notes already. So group 1, most reactive, then it's highly reactive. This entire middle section is mostly stable. And then we go back to highly reactive with group 17, and then non-reactive for group 18. Okay, so this is information learned in our most recent cycle. It is characteristics of metals, nonmetals, and metalloids. Metals are great conductors of heat electricity. They're malleable, they can be stretched into wires without breaking, and they usually have a metallic luster or kind of a silvery color to them. Most of our metals are solid except for mercury, which is a liquid at room temperature. Nonmetals are the exact opposite. They are very poor conductors of heat and electricity. We like to say that they are good insulators. They are brittle, so if you try and hit it with a hammer, it's just going to fall apart. They're non-ductile, which means we can't stretch them into wires, and they do not possess a metallic luster. They're usually fairly dull in appearance. They can be anything from solids, liquids, and or gases at room temperature. A lot of them do happen to be gases, though. Okay, so depending on the location of your element tag on the periodic table, you can tell if it's going to be a metal, metalloid, or non-metal, and then because you know its classification, you'll also be able to tell what that element looks like without ever having to look it up or Google it. So everything in blue is metal. Those are going to be all of your elements on the left-hand side, except for hydrogen. Hydrogen is a nonmetal. It is a gas. So all of our nonmetals are on the right-hand side. We have usually on most periodic tables, or at least a good periodic table, a bolded line or staircase on the periodic table. Anything that shares a side with that staircase is going to be considered a metalloid, except for aluminum. We all have previous experience with aluminum. We know aluminum is shiny, it's a great conductor, and you can bend it without breaking it. We know aluminum is a metal. So that's that one tiny little exception to the staircase rule. Metalloids have some odd characteristics. Each and every one of them is very different. It can have any combination of characteristics of both metals and non-metals. Okay, so here I have an element tag of fluorine, and we're going to go through the different ways that you can tell all about that particular element. So information that you can get from an element tag. This is really great stuff to write down if you don't have pencil and paper next to you. You can get the number of protons from an element tag. So for example, the atomic number is 9, so I know I have 9 protons for fluorine. You can get the number of neutrons by taking that atomic mass and subtracting that atomic number. So 19 minus 9, so we have 10 neutrons for fluorine. We can tell what the mass is. The mass here is 19 for fluorine. We tell the number of electrons, again from our atomic number, same number as our protons. So fluorine has 9 electrons. And of course we have our atomic number in the name of the element. You can get all of that information from an element tag alone. All right, so let's say you have a picture of an element. What information can you get from that? Again, this is really great information to write down. If you have a Bohr model or a model of a particular element, you can tell the group number by looking at the number of valence electrons. So for this particular one, it has 1, 2, 3, 4, 5, 6, 7 valence electrons on its outermost ring, which means that it's going to be in group 17. You can also tell its period number from counting the number of rings. So we have 2 rings here, so we know that it's in period 2. Valence electrons, you can literally just count them up on the outside. Number of energy levels, we did that too. You just count the rings, and then we can also make a prediction about its reactivity. Again, based off of its valence electrons. If it has 7 valence electrons, we know that it's going to be in group 17, and we know that group 17 is highly reactive. Okay, and then our last one, we have what info can you get from the location on the periodic table? So, based on where it is on the table, you can tell these different pieces of information. You can tell its reactivity. You can see a kind of bolded fluorine on that tiny little periodic table. Again, it's in group 17. And we know that group 17 is highly reactive. We can tell its classification. Since it is that far right on the periodic table, we know that area's classification is nonmetals. And because we know it's a nonmetal, we can also predict its physical characteristics, meaning it's going to have a dull, no shininess to it appearance. It's not going to be malleable or ductile, and then it's not going to be a good conductor, okay? We can tell those things about that particular element just by where it is located. We can also predict its valence electron number, group 17. It's going to have 7 valence electrons, and its energy levels. It's in period 2. It's going to have 2 energy levels. Okay, I know that was a lot of information. That was over a lot of different cycles, and I'm hoping that you're starting to kind of pull together all the little pieces and seeing that all of these cycles are related. A lot of this information builds on one another. Okay. If you have any questions, make sure you reach out to your teacher. If you want to rewatch this video so you can take notes, this screen right here is really important to include. All right,